if you've been following along with this unit, this is like our first time we even actually talk about climate change, and what that means and what its impact is, because it's so important to have that strong science basis. I know I keep saying that over and over and over again, but with all the debate around climate change, which frankly, there is no debate. Like, if you understand the science, like, climate change makes sense. So that's why I really harp on the science behind it. Now let's talk about the impacts. Before we even start talking about the first impact, as a very quick recap, humans burn fossil fuels and just fuels with carbon in them. That's why they make such great fuels, because they have carbon. In order to burn things, it has to be in the presence of oxygen. So together, you're going to create carbon dioxide. That's a given. Humans are doing this a lot. So carbon dioxide in our atmosphere have been increasing a lot, and we have data that shows that. And we know carbon dioxide, because of its molecular structure, is a greenhouse gas. And we need greenhouse gases. Greenhouse gases are important. The problem is just we're getting a lot of greenhouse gases, which means we're enhancing that greenhouse effect. All right, so that was like all like hours of videos, kind of nutshell in like 30 seconds. If any of that you need to go back and review, definitely do so, because it's, again, really important to have that strong scientific basis before we go into this. So let's talk about the most maybe immediate, or I don't even know if that's the right word, obvious impact that increasing our greenhouse gases has done to our atmosphere. And what it's done is the average surface temperature has increased. This should make sense. You increase the amount of greenhouse gases, you're going to increase the temperature. That is a greenhouse gas's job. But by how much? So first, let's start off with where this data is coming from. So this is coming from the US government. And if we look here at the rank, so this is saying the hottest year, the second hottest year, third hottest, etc. In this period of record, 1850 to 2023. 1850 is pretty much how far back our data goes, where we can also reliably trust it. We've been measuring temperature for longer and before 1850. But that doesn't necessarily mean we can, I wouldn't say trust the data, but our tools have improved over time. So this is kind of this 1850 to present day is kind of like what scientists feel is accurate enough to use. So we're looking at all the years. That's what, 1819, this is 173 years of data. Now let's look at the top 10 hottest of those 173 years. So the hottest year on record, this video is being made right now, March 2024. So we don't have 2024 data yet. The hottest year on record was last year in 2023. Cool. 2016, 2020, 2019, 17, 15, 22, 18, 21, 14. In case you haven't noticed yet, the past 10 years have been the top 10 years. It's crazy. So if you go through my YouTube channel and you look at some of my old videos, like you'll see this list like throughout the years. So 1998 used to be on here, and that's not because I've been teaching for forever. 1998 was like an unseasonably warm year, and it's like in the years of like all the 2000s and stuff. But 1998 is now out of the picture. The top rankings are all the past 10 years out of a 173 year record. That is insane, and that should scare you. Now, how much though? How much increase has there been? So these two columns, anomaly degrees Celsius and anomaly degrees Fahrenheit. If we took the average temperature from 1850 to 2023, if we took the average temperature of those 173 years, it's X. It's some value. Anomaly means if we take a look at that average, how much warmer or how much colder is that temperature from the average. So if the average, I'm making this number up, if the average was 10 degrees Celsius, we're saying in the year 2023 that it was 1.18 degrees Celsius warmer than that average of 10. If these values were negative, we would be saying they're colder. So you might be looking at this, you're like, okay, oh, We're a little over 1 degree Celsius higher. Like, that doesn't sound bad, right? You go outside, you would not feel that difference. 2 issues with that. 1, this is an average. On the next slide, I'm going to show you a map of how temperatures are changing globally. Some areas are getting cooler. Some areas are getting warmer. If we average all those up, we are on the higher end. This means some areas of the world are getting a lot warmer than this. Second thing is perspective. The last ice age, so the one where we made a movie about it, there's Mammoths. That last ice age, Earth was about 6 degrees Celsius colder than the average. So 6 degrees difference was the difference between ice age or not. We're at 1 degree, but on the warmer end of things. So now that 6, or I should say this 1, is a lot bigger, so to speak, than it sounds like. So don't underestimate that 1 degree. Now, I mentioned we're in 2024, but we're really early in 2024, so we can't say yet where it's going to fall on here, if it's even going to fall on here. It also takes a couple of months for data to be verified before it's published. So far, the only data that's been published was on January 2024, and it's the hottest year on record. So of all the Januaries that we have data for, January 2024 was the hottest one on record. So probably going to be in the top 10, but we don't know yet. And if you take a look at some of the links that is in the description, I'll link you to where this data is coming from. So if you're watching this video later on and you're curious where we're currently at, you can take a look at those. Now, as I mentioned, we're talking about average temperature. Some areas of the world are getting warmer, some are getting cooler. It depends on the month too. So what this world map is looking at is looking at land and ocean temperature, and it's in the percentiles, and we'll talk about that in a moment. And this is specifically looking at this January. Remember, January, the hottest January on record. All right, so any area that's like white is near the average, meaning that area kind of on track. Similar January to last January and the January before that. So if you look at the average January temperature, they're pretty similar. If you look at the United States, a good chunk of the United States is about average. They're fine. If you look at the darkest red, these are areas that experienced a record warm. So a lot of our Atlantic Ocean, we're going to talk about why that matters here in a little bit. So a lot of the Atlantic Ocean had its record warmest January. Parts of South America, parts of Africa, parts of the Middle East, parts of the Pacific. So a good chunk of the world having their record warmest year. But again, on average. Record coldest is the darkest blues, which really the only one that had their record coldest are parts of Antarctica. And then much cooler than average, some parts of the United States and like different pockets here and there. But if you look at this map is a majority of red, which is why when we're talking about average temperature, yes, there's cold areas, but there's so many more warm areas that average is warmer. So just using this map to kind of help explain that yes, some areas are getting colder, but a majority of areas are getting warmer, which is what drives that average to be warmer. Now, temperature in and of itself has its problems, especially when it comes to human health. But temperature really dictates and drives a lot of our local and global weather patterns. So for here, I'm just focusing on the United States because I like the graininess of this picture. This is looking at precipitation. And the scale is using percent. So 100% precipitation, what that means is compared to the past, if it's 100%, that means you're getting about the same. You could almost think of this as average is 100%. More teal is you're getting more rain than average, and more tan, you're getting less rain than average. So you can kind of read it very similar to the scale on the previous slide. So you can look out west, quite a few pockets where it's typical you'll notice there's actually a lot more rain in a lot more areas. Um, 200% more rain in quite a few areas. Some areas, are getting less than 5% of the rain they've gotten in the past. So North Dakota is having areas where we're getting so much less rain than they usually do. Parts of Texas, so much less. Other parts of Texas, so much more. There's this dichotomy. And this can be an issue. So weather's not impacted the same. In some areas, you're getting more drought, and in other areas, you're getting more rain. And you're probably like, why is it not all the same? One way to think of it is rain comes from drought, right? So a drought-ridden area, essentially there's no moisture in that air, but there was moisture at some point, and all that moisture, all that water was like sucked out and transported and dumped somewhere else. So it's not that we have more water on Earth, it's just water's getting redistributed. That's probably a better way of putting it. Warm temperatures will carry more moisture and then literally carry it elsewhere and then dump it elsewhere. Now you have this dichotomy, and it's hard to treat, so to speak, because some areas are experiencing lots more flooding, some areas affecting a lot more drought. And while that affects a lot of human infrastructure and things like that, probably the biggest issue with these changing weather patterns is to agriculture. Plants tolerate a certain amount of water. If you're in a drought, you have to use more water to help your plants, which may not be around. And you might be like, oh, well, we'll just start growing them in areas that have more water. Cool, but plants can drown too, right? You give too much water to plants, that can kill them. So there's no one thing that kind of addresses this issue. So just know that our weather is changing, and that's going to have impacts to human infrastructure, human global food supply, and a lot of other things, because things are becoming more unpredictable. And related to unpredictability, one type of weather system in general that's going to be affected even more are hurricanes. So hurricanes are these huge storms that come out of the Atlantic Ocean, and they're fueled by warm water. I'm actually going to backtrack a little bit. In our warmest January, you might notice that a lot of the Atlantic water was at its record warmest. And that makes me worried about this year's hurricane season, because hurricanes need warm water in order to really form and grow. And the more warm water you have, the more hurricanes you have, and the more severe those hurricanes have. Here's some pictures of past hurricanes that have hit the Atlantic coastline. And so I grew up in a hurricane state, and I can't even really begin to tell you the impact that a really bad hurricane has to a region. But I'll give you dollar symbols. So if we were to just rank the costliest seasons, meaning they did so much damage to repair buildings, homes, commercial centers, roadways, to rebuild the damage caused by hurricanes, the most costly seasons are, again, more recent seasons. The most costly season in 2017, $295 billion, followed by $118 billion in 2022, and just the year before in 2021, $81 billion. This is a strain to our economy. And they're only going to get worse. As our oceans are warming, specifically the Atlantic Ocean, we're going to keep seeing this issue with hurricanes. Now, there's other types of storms. There's tornadoes, there's monsoons, there's nor'easters. Those are caused by different atmospheric conditions as well. None that are really too controlled by climate change or really too controlled by temperature, as much as hurricanes are, which is why there's been a lot of focus on hurricanes and not so much on other storms for people who are examining climate change. And then we're still talking about temperature, but let's talk about not humans, right? So other things exist on Earth. I'm still going to tie some of these to humans, but still. So the first one that I am going to tie to humans is insects. Insects love warm weather. Like, that is when they are out. When it starts getting too cold, they either die or they lay eggs, and their eggs stay like underground or whatever, and they emerge when it starts warming up. Well, if your winters are getting shorter, if you're experiencing warmer temperatures, insects will emerge earlier. They'll be able to reproduce more because they're out more. Now, for some insects, you're like, okay, cool, that's fine. For insects like mosquitoes, not great for humans, right? Because this means we can have more disease transmission. So things like malaria might increase in populations, or West Nile virus might increase in human populations because mosquitoes are around longer. Agricultural pests are also going to be an issue, right? You might be like, oh, warmer temperatures, farmers can grow more. Yeah, those insects are reproducing a lot faster than our plants are. The amount of additional corn we're going to get is nowhere in comparison to the amount of corn pests that we're going to have. So this is mosquitoes. Now, you'll notice it still says insects emerge earlier, and I got this moose. Moose are not insects. They're mammals, just like us. But there's this research going on in Canada about tick infestations. So ticks aren't insects, but for the purpose of this video, imagine they are. Also rely on warm weather. And Canada, a fairly cold place, is experiencing a whole lot more ticks. And they were doing the study on mooses. On moose. They were doing a study on this animal where they're finding carcasses that literally have hundreds to thousands of ticks on them, which they never did before. Like this, or if they did, there might be 1 or 2 ticks. But the ticks are expanding their range. So not only, in areas where we always had ticks, we're going to see more ticks. Ticks are able to go into new regions because the temperature is warm enough for them to do so. And just like mosquitoes, ticks can carry a lot of diseases too. Something else we're going to start seeing, something we're already seeing. I focus on this guy. This is the American pika, which is where the name Pikachu comes from, just FYI. And what we're seeing is that organisms that have pretty small ranges are getting even smaller, which is probably going to end up pushing them to extinction. So I'll use the American pika as an example. So they are mountain species. Mountains in the United States do not look like this, but imagine, if you will. And let's say the American pika lives pretty much just on the snow-capped mountain part of mountains. Cool. And that's great, because there's not a lot of things that live up there, so they live a good life, they get what they need, they don't get really predated upon, because it's, for the most part, just them. They're really well adapted for this kind of extreme environment. The problem is with this increasing temperature, their range is getting smaller. Okay, that snow doesn't go as far down the mountain anymore. So maybe in a 20-year period, they've got less of a range, and maybe this is okay. Another 20 years, okay, we're getting smaller. Okay, we're probably starting to see a decline in the population. There's not enough space, there's not enough resources. They're just not doing as well. And eventually, and in some areas in the United States, we are literally losing our snow-capped mountains. And now there's nothing there. And it's not like the American pika is just like, I'll just go to the mountain next door, because the mountain next door is probably experiencing the same exact issue. So problem is that organisms that have a really narrow range, they're going to be impacted by these changing temperatures because it's probably going to mess up with their range. For some species, it might be okay, but for other species, particularly those that rely on this cold weather or these cold habitats, will get pushed to extinction. Now, you might not care about the American pika. I get it. We as humans don't really get a service from them, but think of them more as a signal. Their extinction due to climate change is the first to come, not the last. This organism might not impact us that much, but how long will it be before it does start affecting organisms that we do care about? So with that, the most obvious change or impact of climate change is our changing temperature, and that changing temperature is going to make a huge impact to a lot of things. This video just explored the impacts to, temperature as a whole, but also looked at the impacts of our storm systems, like hurricanes, as well as just regular weather patterns, and then also those subsequent changes to our organisms that live on Earth. Future videos are going to look more at like ice, so what's happening in Antarctica, the Arctic glaciers, as well as other things that we as a society can do to mitigate those changes.